Right, question 1, a straightforward differentiation question. So to differentiate this function, we take the power, which in this case is 3, bring it down, multiply it by the coefficient, simplify and reduce this power by 1, and we go through the whole equation. Okay, I can say that dy dx. 3 multiplied by 2 over 3 is 2, and we reduce the power from 3 to 2. Negative. 2 comes down, multiplies by the 7 over 2, we get 7, and this is just x. The differential here, effectively, it's the same. We're bringing the 1 down and reducing the power of the 1 to 0, so the x term will effectively disappear. So this is just negative 4. The 5 differentiates the 0, and that will be the answer to part A. Part B. Find the range of values for x for which y is decreasing. So if this is the shape of our curve, and I'm certainly not saying it is, the value of y is decreasing all the way up to this point here, and from this point the value of y increases. And what distinguishes the decreasing values of y is a negative gradient. So we've got to find out when our gradient function is less than 0. And if you put the values of 2, negative 7, negative 4 into the calculator, out will pop this answer, which will get you your 4 marks. So if we were to do this manually, I would make this equality an equation equal to 0 and factorize. And it factorizes quite easily. And it gives you the factors that x must be equal to negative a half, and x is equal to 4. Remember, these are the goalposts. We bring back the inequality, and we can state that x must lie between negative a half and positive 4, but not reaching either of them. And that's your answer.